everybody. Welcome to Let's Learn Advanced Excel. I'm your instructor. Guys, today we will be covering solver add-in. What is solver, guys? And why do we need this solver in our Excel file? Solver actually is hidden feature in Excel, and it's actually optimization tool which works on the basis of some constraints and some limits. So you can see solver is a Microsoft Excel add-in program which we can use for optimization like what if analysis. So in our previous videos we have covered what is what if analysis. So same way, this is advanced version Excel solver where it works on the basis of some constraints, where we give the constraints and it gives the output accordingly. So you can see that generally solver doesn't come by default in our Excel file, that we have to install and follow some steps mentioned here. So what is actually solver and how it can help us in this regard when it comes to optimization? And it can help us to solve a transportation issue, it can help us to solve financial issues, where or maybe when it comes to production, how much we have to produce to maximize the profit. This actually comes to rescue. So now you have brief idea about where to work, and let me tell you something. Actually this solver add-in is working on the basis of three solving methods. But one of the methods today we are going to discuss in this session is linear programming. And let me tell you something about linear programming. Actually, it's a form of mathematical optimization that actually helps to find out the best way of using limited resources to achieve a given objective. And there are some key variables in this linear programming: decision variables, objective function, constraints, and variable bounds, and it works accordingly. So the same way, but actually when we have mathematical representation of a problem, we can't solve that without this solver add-in. Though this solver kind of representation can be made either in Excel or in other programming language, but in Excel actually it's very easy to use. Let me show you first how to activate this solver add-in. So you can see this screen. We have to go to option and then we have to click on add-ins, and then after we clicked on add-ins we have to go to Excel add-ins, and then this dialog box will open. We have to click on OK. So once you OK, so solver will be reflected in the data tab solver. All right, let me walk you through again. Go to option, and after you go to option you have add-ins. You click on add-ins, and then at the bottom you have Excel add-ins, and go and then select a solver add-in. Let me show you the same in Excel file. Though I have already installed a solver in my Excel file, so I just tell you, go to file and go to option. Once you go to option, you click on add-ins, and now you can see Excel add-ins below. Click on go, and now solver add-in, you check it and then OK. After that you will find the solver will come here. It will take maximum half minute or maybe 1 minute, so it will come there. So guys, this solver is very much useful when it comes to optimization of the resources, optimization of the profit, and it is very useful in getting us the optimal result. So same way, solver actually it's optimization tool that is used to find out the desired outcome on the outcome which actually can be achieved by changing the assumptions. Let me tell you some example, guys. So in solver, let me tell you one example which is the most used today, and today we'll work two examples where we have complex calculations and we have some basic calculations, so that basic calculation can help you better to understand. Assume we have three product. Assume we have three product A, B, and C. Okay, let me write down somewhere else. We have three product A and B and C, guys. We have three product A, B, and C. All right, and the condition is that in the factory we have to produce minimum, or at least you can write at least we have to production Let me make it simple example for you guys so that it can be easy for you to understand better this optimal solution through Solver add-in. As I mentioned already, Solver is a hidden feature that we have to install it by going to File, Options, and Add-in, Excel Add-in, and then it will reflect in the Data tab. So over here, we are actually working on a mathematical representation of a business problem where we have to find out the maximum profit. So now the condition is that this is the basic example I'm taking. Minimum 100 quantity we have to produce for A, and second is 20, and let's assume we have third 50 guys. So you can see the total, their minimum at least quantity we have, and they're telling total you can produce maximum 360. Total 360 we can produce, total limit. So you know, these are the constraints, guys. These are the constraints where we have to make the production. And now they are telling, you know, the price, profit per unit, you can say profit per unit. Let me copy this, Control C, and paste it somewhere else. Let me make some kind of questions where you can just take the insight and make some business representation of the problem, and then we can run our solver. So now the profit per unit, profit per unit, let me put some data. Profit per unit, let me put one example, 10. All right, and 16, and let me take 32. So this is profit per unit, guys. All right, so now we have the data. Now we have the data where we can actually run our solver, but we don't know what quantity we have to produce, guys. So what quantity we have to produce, that we have to find out. So now we have find out like what quantity, and then maximize profit. Maximize profit. So now there are two things we have to find out. Let me make one business representation. So you can say this is the product, and product we have A, and then B and C, guys. Understand this. And this is the quantity. So quantity, we don't know what quantity we'll get. Let's assume we have 0 quantity first time. With that, we have to find out. Now the business is asking, if I have these constraints, like A product, at least 100 item or unit should be produced, B 20 and C 50. We have the profit per unit 10, 16, 32. So you can say that profit per unit. What we can mention here, you just copy this data and paste it here. So we are actually formulating a model so that we can run our solver. Now we have these things, you know. Let me make it bold, Control B, and let me highlight that, Alt H B A. So the condition is that now total profit, all right. So how to find the total profit, guys? Equal to this multiplied by profit per unit. All right, so our total profit is also 0. Now let me tell you something. This is actually our here you can use sum of all three. So there are two things where you can do this way. I will tell you another way also where you can use some product function. So this is actually my total profit, total overall profit. So this actually is the total. Let me make it color. Okay, and Control B again. So guys, this is one scenario. Okay, and minimum is 120 and 50. They are my constraints. All right, minimum A should be 120 and 50. Now you have to tell me how we can maximize our profit. Let's open the solver now. We have to go to data, and then we have to go to solver. Once we open the solver, actually we want maximum profit. We want maximum profit of this cell. So you can say we have selected total overall profit D5. We have selected, we can select maximum, minimum, a particular value. Let's select maximum by changing variable cells. We are changing these cells. Okay, and now subject to constraints. See, it is very simple. What we are doing, we are maximizing the profit, and we are changing our variable cells that we have selected B2, B2 through B4, which is there. Now we have to add the constraints. Guys, constraints means this item quantity, when we talk about at least, so it should be greater than equal to, it should be greater than equal to 100. You can just add this. Now we have to go to second, which is this. Again, we have to make greater than equal to 20. And now let's make it third one. Again, we have to do greater than equal to, and what should be the constraint? Of course 50. And now we have to add this also. Okay, now there is another constraints. So let me just first let me make it the total sum. Okay, let me make it sum here first, or let me make it cancel first, because everything is available there. And you can just escape, and now you make sum also, sum of all the quantities, guys, that we have not done. So sum actually 0. Now go to solver, because everything is already there, whatever you have selected. And now you have another constraints. The total, this should be equal to, you can 360. All right, and now you do okay. Guys, now you see that everything is made now. B5 equal to this, and so on. And you can see make unconstrained variable non-negative. So because of course we want quantity in the whole number, or maybe positive number. And select a solving method. You can see there we have three methods: GRG, nonlinear, simplex, LP, evolutionary. And once you click this, you can read everything about these things. All right, solving method, select the GRG nonlinear for solve problem that are smooth nonlinear. Select the LP simplex engine for linear solve problem. Select the evolution engine for solve problems that are non-smooth. So over here the data we have available with us, it is the basic data. And simplex LP is the most suited example for this. Now I have to click OK, solve this. So see, objective cells must have the formula. So now you see we have selected by default C10, but where we have to select this cell. Now select this. Are we getting the output? Yes, solver found a solution. All constraints and optimality conditions are satisfied. Now you see this is the maximum profit and 360. Now you see overall 360 we have to produce, and you can say at least 100 is produced and at least 20. And here we are telling at least 50 should be produced, but our solver has proposed if you produce 250 for that, then you can have maximum profit. All right, and now let's do this with simpler GRG nonlinear. Okay, and solve this. So now you see that it is also getting us the same output. Let me make it 0 and 0 and 0. Let's run this again. Now see that it is also getting us the same output, but here it is telling rather than 360 250, it is actually same thing it is proposing, but here we are getting total profit in this way, 32, and what it is giving to 240.001 and whatever. So now I hope you found this useful, because with this example we can actually perform lots of things. Let's take another example. What if somebody is telling us that you can produce total 500 minimum, total 500. All right, and let me make it 0, 0 and 0. So now someone is telling at minimum actually this and minimum 50. So this is the minimum criteria. At least we have to produce this much item, and now this is total limit. How to solve that? Go to solver. First you reset all. So after you reset all, everything is gone. Now set objective. This actually I want a value of, maybe I want 7,000. Assume that maybe I want 12,000 profit. Okay, value of 12,000, and this is the quantity. This is the variable changing variable cells I want. Constraints. What is the constraints? I want this greater than equal to this, you can add this, and now this again you put greater than equal to this, add, and now again you go there, greater than equal to, select this, and now add. There is one more, this should be equal to this. All right, and now do okay, because all the constraints we have supplied. Now solve that. So now you see that solver could not find a feasible solution. So but we wanted 12,000, and it has given us this outcome where you can have total 500, it is satisfying the condition, and minimum 100, it is also 150 million, and rather than at least 150, it is getting us 280, because it's not possible. So maybe you can have some kind of scenarios. Now it is clear to you, if you have proper data modeling or mathematical representation of a business problem, then you can run the solver to a requirement. So let me tell you another example that we have to make again the business representation of a problem where it can take some time, but let me take this opportunity to tell you how solver can be effective. First you go to solver, everything is reset all right, and then close that. Now let me make it some example for you. There are three factories where we are using storage expenditures. You can say storage is also a problem. Storage expenditure, storage expenditures, and now we have capital. Okay, these are two expenses where we are making storage and capital. So now the condition is that there are three factories, so we have to make multiple tables, guys. Multiple tables we have to make. So let me take some table first. There are three product, P1, P2 and P3. All right, so P1, P2, P3, and this is my factory 1, and this is factory 2, and of course this is factory 3, guys. All right, so factory 1, P1, you can say this is the profit. All right, so let me merge this. So profit, I need your attention here because we are making complex solver add-ins. Some business problem we are solving here. Profit per unit. All right, so this is profit per unit. Make it color. And now what's profit per unit? Let me tell you one data we have. Suppose some data, I'm just making some dummy examples for you. We have 19 and we have 38 and we have again 38. All right, and now let me take some example. We have 18. I'm just making some example by myself. 39 and now 25, and now product 3, 27 and 42, and let me take this 22. Okay guys, this is profit per unit. Let me just alt HBA. I hope it is clear to all of you. This is factory 1, factory 2, factory 3, product 1, product 2, product 3. So 19, 18, 27, 38, 39, 42 is correct, and 38, 25 and 22 is also correct. So guys, this is one table we are specifying profit per unit. Second, also we have to make, just let me copy the same table, so that because the same format we need, and here we are telling factory production that we have to calculate. Factory production we have to find out here, which actually is 0. We don't know what is the factory production, that we have to optimize. So what we have to find out? Factory optimize production for all products. So now you see factory optimized production for all products. So this is the profit per unit and this is the factory production. All right, now as I mentioned, storage and capital, they're also our expenditures. So now storage, so let me make it storage over there, and storage used we can use, and storage available. available. So what does it mean? Storage available mean this is actually our budget, only this much we can use it, and this is something which is used basis on the production made. So now what actually available here, let me make it 2500, and let me make it 9500, and let me make it 10,000. Guys, this is actually our data, profit per unit. This is actually the data which factory has given us, and storage available, this is the storage available with us. This actually we have to find out all three. So maybe let's shift this control X here, so that it will be in the continuous header. All right, now what actually we have to find out again, we have to go again that factory storage. Product wise we have to find out the storage. What is factory storage? That we have to give 4 4 3 4 and 4 and again 3, guys. And what is factory 2? Let me take 5 and 5 and 9, guys. Okay, and this is 2 and make it 4 and 4. So this is actually our expenditure, which actually we are making product, product 1 for factory 1, product 1 to factory 2, and so on, because it is varying from factory to factory. This is factory storage. Now I have another table which I have to make for, factory, capital we are using. Capital. So the capital what we can do use per unit we can use here 16 and make it 12, 17, and what is that capital? 7 and 3, 7. I'm just putting some dummy data. 13 days, and we are taking this. All right. So this actually is the data for capital we have, and now we know that this is the storage. And let me copy the same, control C, and let me make another table for capital used, and now capital available. Guys, this is a very complex problem of business where we have to solve and find out the optimal profit. All right, and this is 10,500, this is 12,000, and now this is 29,000. All right, so guys, understand now how we can solve our this business problem. What is capital used here? So now you have to use this function, capital used. So you have to use some product. All right, some product you have to use, or let me tell you something that we have to think a lot over there. So have patience. Let me think. We have made our business business problem, and now we have to find out the total profit. Let me make total profit. But now total profit, how we can optimal the total profit here? First, storage used. What is storage used? For all three we have to use to equal to, you can use some product. All right, and select all three, comma, factory storage is this one. All right, this actually you have to do this way, and you can drag this. So after you drag this you can see it is just copying the second row, and if you go there you can see it is just third row. All right, factory production, factory storage. Now capital used, again you use some product. Guys, some product is the most used function in solver. Now capital, so capital means this is the factory this is a factory production which we have to find out, and now this is our capital, guys. Okay, so once you click this, so now this is actually the thing we have, capital used. And now this, let me just remove everything and make it this way, control X, side by side, so that it will be easy for us to find out some product, this, and this is the capital we are using. Now this actually some product, no, not profit, we are doing something wrong. Some product, factory production, comma, capital, guys. Okay, this is superb. So now you see this formula we have to drag. So what is the profit, guys? Equal to some product, total production multiplied by total profit minus minus some product. Again you have to use some product. Total storage you have to use. So total storage, total for factory production, comma total storage, guys. Okay, फिर minus some product. Again you have to subtract again factory production, comma. Now capital we have to use because capital comes in B24, that we haven't used by now, and that is the capital we have reduced. So now you see, again you see the formula. This is factory production storage. All right, and now if you go there, escape, check this formula again. This is factory storage, B10 and B10 to B12, B10 to D12. So B10 to D12 means factory production, and B24 to D12. This is correct actually. This is correct. B10 to D12, and then we are using this. This is perfect. All right. So now it is done, and we have got the profit, and we have storage used, and we have this. Let's run the solver now, guys. I hope you are ready, because we have to find out the total profit and production, how much we have to make to get the maximum profit. So let me go to my data, and this is called business representation of the business problem. Okay, mathematical representation of business problem we have ready. Let's start with solver. Solver, what we have to do, this actually we have to do maximum, which is perfect, by changing variable cells. Guys, what does it mean by changing variable cells? Of course, this is the thing. All right, and now what is the constraints? If you go to the constraints, this actually we are telling less than equal to this. All right, because this is less than or equal to this, we are telling constraints. 1 minute, that we have to use this less than equal to this. Now it is clear. F3, F5, G3. This is we have done one constraint. Second constraint is storage. This also less than equal to this. This is also done. And now, but again we have to find one more thing, guys. Let me close this. Two constraints we have add. You know, again we have to find out total manufactured item, because that we have not add, because we have to add a total manufactured. So total manufactured or total production, you can say total production. Total production. Total production, we have to use some function here, and now for factory production this. All right, so this is another constraint we are adding. And now total demand, they are telling total orders, or maybe total orders, you can say some limit like 1650. Let me take, and let me take 1800 here. Let me have some 1180 data. Okay, so they're telling the total order which we have to accept should not exceed these limits. So they have given this, which is actually coming from that. So let me go to solver again. So solver actually selecting data correctly, total profit, which is 16. And now let me add another constraints. The constraints we have, this should be equal to maybe this data. All right, now do okay. So guys, we have added all the constraints and everything. Now let me run the solver. So factory, storage, and capital, let me show you the example. Profit, it is actually getting me this integer values and everything, so I don't want that. Let me go to solver again and add one more constraints. I want these values should be integer values. All right, add this, and now cancel. We have added that, and now solve that again. Solver found a solution. All constraints and optimality conditions are satisfied. So now this is the total profit which we have to make. We have made profit per unit and factory production. So our solver is proposing in the factory one, for product one, don't produce anything because it is 19 profit. Produce the second. if you want maximum profit. And factory 2, it is proposing one, this and this. All right, because maximum, if you see, it is coming 1800, which is the maximum, and this is the one. So this is how the maximum profit can come. All right, I hope guys you enjoyed this session where we have explained. Now you see total production, where we have applied the formula, and now total orders. So the constraint was total production should not exceed this total orders. So that was the constraint. So this mathematical representation of a business problem we have solved through solver, and this is the profit which is proposed by the solver. And trust me guys, this is not at all easy if we do manually, because manually it will take lots of time. You have to have multiple variables, and you have the solver. In the solver, if you go, you can have other constraints also if you have, and you can just see it actually works like a charm. All right, and now see that. Let me give you one more example. If someone tells me that production should be 2000 and it should be 1200, okay, and it should be 1700, assume that. Now let's run the solver. You can say 038, this much we have. Run it now. See, solver could not find a feasible solution. Still you can say that 1107, and this again we have to put a condition over there, maybe one more constraints, add, like this should be equal to integer, maybe you can say integer, and then okay. All right, so now see that value is not taking because this should be integer. All right, b times 29. So maybe just close this. Integer constraint must include only variable cells, so it's not working. All right, because this actually we have proposed already. You can play with this data. All right, and let me just run once again what best we can do. Okay, yeah, this was wrong. This actually we have selected this. Now let me run, because if you run multiple times, it actually select the different cells. It should be integer. Okay, integer constraint cell reference must include only variable cells. Let me run this now. Integer. Not find it. So maybe let me put that. Let me put another example. 1650. Once again, we are putting the same example. Okay, 1650, and now we are putting 1700 and 1180. Let's try with this example. Okay, just run that. Solver found a solution. All right, see that solver found a solution. So this is factory production we have. It is proposing now this. So you can run it as much as you want and see that what maximum profit you are getting. You can add multiple conditions, constraints. So while adding the condition, you have to be very careful that if you have to add some more constraints where you want binary value or integer value, that will work superb, guys. Okay, now you see with this basic example, we have got this maximum profit, and this is the proposal. And now whatever we have made, it has changed the value. Now for 1700 for second, it is proposing this much value, and 1180, it is getting us 1180 exactly. You can see that this is the formula we have applied. So you can run, and solver first example was basic, where we have just used quantity and multiplied by profit, and this was the constraints total limit, and we have used the solver and got us the optimal profit. Solver second also, we have multiple variables, and we have this capital and storage. That's why in the profit we are reducing capital and storage. So this is the optimal profit. I hope guys you found the session useful about solver add-ins, and really wonderful tool which you can use in your process to solve a business problem. And this solver can easily be used to solve a transportation issue or some financial budget constraints issues. So this is amazing. Thank you very much. Have a wonderful day, guys. Bye bye.